All right, so now we're going to talk about basic derivative rules. You're going to have to memorize all of these. But this is going to allow you to get around having to do the limit process all the time, which is nice because that gets super tedious. So, basic derivative rules. When you are taking a derivative, you are differentiating. That is the verb of what you are doing. You don't say that you are deriving. That means something completely different, okay? So when you take a derivative, you're differentiating. So they're basic derivative rules. You can also call them basic differentiation rules, okay? Some of them have names, some of them don't. So first one is the constant rule. So constant rule says that if you're taking the derivative, and this is that notation that I said got used for formulas mostly, the derivative of a constant is 0. Any constant, whether it's 3, 12, 562, whatever, okay? If f of x is a constant, its derivative is 0. No work goes into that, okay? These problems are nice because they tend to be pretty quick once you know the rules, okay? So the next one that is going to be one that you use a lot is going to be your power rule. Power rule says that when you're taking the derivative of x to a power, what you do is you take the power, you pull it down, and then you reduce your current power by 1. So now we're going to do a couple of those. Since these are videos, something handy is after I write the problem down, I would pause it and try to figure it out, okay? And then go back and see if you're right. Don't just watch me do all of them. That just establishes that I can do them, okay? So pause it, try it, see if you get it right. So then here, first derivative, you're going to take the 3, pull it down, reduce your power by 1, okay? Let's say that we have, okay, so this one, the derivative is this. The reason that it works out like that. Now notice I did this in my head. For the time being, if you have to write the extra steps down on paper, that's fine, but you want to fight to be able to do this in your head. So when you have an x squared on the bottom, what that means is that you have x to the -2nd, okay? So to take the derivative, you take the -2 and you pull it down, and then you would subtract 1. So -2 minus 1, you have -3. Now here's going to be my rule when it comes to having negative powers. You cannot leave negative integer powers. If this had been -2/3, -1/2, I don't care if you leave it looking like this, okay? But if it's an integer, where it's not a fraction, you need to put it back on the bottom where it belongs, okay? Don't leave it like this, pull it down. If you leave it like this, and I catch you doing that, it would be wrong, okay? Because it takes practically no effort to do this, okay? So right now, I wrote it down. If you need to write it down for the time being, that's fine, but you want to fight to learn to do this in your head because it will make you better at powers and it will make the problems go a little bit faster eventually. Okay, so like I said, fight to figure out how to do that in your head. Even if it takes a little bit of time now, it will save you time in the long run. But don't leave it like that. Okay, so here we have the 5th root of x squared. So then your derivative, you've got 2/5 x to the -3/5. Because same thing, this right here, when you rewrite it, You go inside over outside, so then you've got 2/5. So you pull the 2/5 down, and you would subtract 1, which is 5/5, which is why it's -3/5. This one is a fraction. I don't care where you leave it, okay? It really doesn't make that much of a difference. You can leave it like this. You can pull it to the bottom. Either of those are fine. What I wouldn't do, only because it doesn't really help, even though it is technically the same thing, is make it the 5th root of x cubed on the bottom. This is just awkward. Looks awkward, it doesn't help you at all. You're not gonna do anything else with it for right now. So any of those 3 would be okay. The only place I'm picky is gonna be here. More practice. One more like this. The same thing, it throws people. Okay, so let's say that f of x is just x. So then its derivative is just 1. The reason that its derivative is 1 is this is technically x to the 1st, which we're forbidden to ever write down because no. You pull the 1 down, and then you would have x to the nothing, which is also 1. So that's why your x to the 1sts are just going to end up being 1, okay? So that's power rule. The next one is the constant multiple rule. What you'll notice is that so far, it's all been 1x to all of the things. Constant multiple rule allows you to do things like 2x or 5x or 7x cubed, whatever, okay? So your constant multiple rule says that when you're trying to take the derivative, remember if you use C or K in the book. C, okay. Of a constant times f of x, it's just the constant times the derivative. So if f of x is 5x to the 7th, you take the derivative of x to the 7th using power rule, where you pull down and subtract, and just when you pull down, you multiply it by the 5. So then you're looking at 35x to the 6th. So then let's say instead, we have this. Same thing. If you have to write down the extra steps, you can. But what you want to work on doing is you want to be able to do this in your head without the extra stuff. That's supposed to be the original problem. To get to your derivative, which is going to be that. And again, the reason that it's that is that here, what you really have is you have 1/3 and you have x to the -6th. So you pull down your -6, so you have -2, and then you subtract, okay? And you get here. Writing this down for a little bit is okay. Writing it down every single time isn't great because same thing, you need to learn to get through this in your head. It's just multiplication and subtraction, which is not so bad, okay? Next rule, I guess 2 rules smushed together, are the sum and difference rules. Really, it's one rule that covers sums and differences. What that says is when you're taking the derivative, and I should have written smaller or started farther left, of a sum or a difference, what you do is you just take the derivative of the separate pieces. I'm going to cheat, put it here so I don't run out of space. Okay, so you hit them separately for sums and differences. So technically all of the problems that I've done so far, I could have done as one massive problem if I had just thrown pluses or minuses in between them, okay? What you have to keep in mind is that right now, you are super limited in terms of what you can do with derivatives. You can do constants, powers, and now sums and differences. Multiplying, dividing, that's too hard. Those aren't things that you have skills to do yet, okay? That comes later. So doing a couple of these. And same thing, like I said before, after I write them down, pause the video, try and figure them out, and then look back and see if you got it right. So it's a sum or difference. You want to treat them all as individual problems. And just deal with them all separately. So you've got negative 40 x to the 7th plus 6 over x cubed plus, you'd write this as 3 halves x squared or 3x squared over 2. It means the same thing. I'm probably just going to write 3 halves x squared plus 3, and then that one's 0. Okay. These are the two that tend to throw people off. So again, this one, if you need to write it out, is negative 3 and then x to the negative 2nd. So I pull down the negative 2, which is why it's positive. And then you have x to the negative 3rd, which belongs on the bottom. Okay. So then this could be rewritten as 1/2 x cubed. So you pull the 3 down, so that's why it's 3 halves, and then you subtract, so it's 2. X, we talked about, turns into 1, so since it's multiplied by 3, 1 times 3 is just 3, and then 7 is a constant, so it turns into 0. 2 more involving sums and differences. Then we have a couple of trig rules to talk about. We're going to talk about tangent lines. Same thing, this stuff is all really, really dense because there's a lot to cover, so the videos tend to get long. I'm sorry. So right now, division is too much. It's not a skill you have. It's too hard to try and do the division. So what you have here is something that you have to simplify because you have lots of things over 1x like that. So what you want to do is you want to take all of them individually and put them over the x and simplify them. Okay? So doing that, 3x cubed over x is just going to be 3x squared. This is just going to be 5x. This is minus 2. This is plus 3 over x. Fine. Now it's a sum and difference, which you are supposed to know how to be able to do, and you just hit them all separately. So we've got 6x plus 5, that's 0. This is then minus 3 over x squared because if you need to write it down, it's 3x to the negative 1st, and you pull down, subtract, and then fix it. Okay? All right, one more. So just like division is too hard for your calculus skills at the moment, multiplication too hard. Okay, this is something called a composite function because something is happening to a quantity. You don't have the skills for that yet. All you can do are sums, differences, and powers. So what you want to do is you want to take this, you need to actually square it out. This you have no skills to do. And that's 0. Okay. Okay. So last 2 rules that we're going to pick up today are the trig rules. They don't have special names. We're just picking up 2 of them. Okay. So the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. It's like they just switch. You just gotta make sure you keep track of your signs, okay? So, doing one example with that. I threw this in because same thing, it's a good idea to practice them all the time because people have trouble with them. In theory, they should be getting easier the more that you work on doing this in your head, okay? So sine is going to change into cosine. So sine with a 3 in front just changes into cosine with a 3 in front. Cosine to sine, you have to change the sign. So then this would be plus 5. Actually change it to sine of x, okay? And again, what happened here, if you need to rewrite it, is 2x to the negative third, and you pull down. So you've got negative 6x to the negative fourth, and then put it back so that it's not wrong, okay? So those are all the rules that we're picking up today. We'll pick up more. So the other thing that I want to do is a tangent line problem, just to show you the difference between the tangent line problems that we did yesterday and the tangent line problems that you can do now. And why we're grateful that we have the rules, other than the fact that you're probably tired of finding the derivative using the limit process. Okay, so we're going to find the equation of the line that's tangent to f at the given point. Okay, so yesterday when we had to find the equation of the derivative, you had to go through and do the limit process with this. This would be obnoxious because that's to the 5th power, even with Pascal's triangle. No. So now, when it comes to finding the derivative, you can shortcut it with the rules that you should now be practicing, okay? So then your derivative, you pull down and subtract. So you're looking at 15x to the 4th minus 8x plus nothing. And then all the hard work is done, and you just plug in 1, that'll give you your slope. And you have the slope and the point, and you're at the equation of your line. You got 15 minus 8, which is 7, so then here's your slope, here's your point. So we've got minus 7 plus 6 minus 1, and that is the equation of your tangent line. And that is basic derivative rules.